Good day, everybody. Thank you for attending today's web meeting called Detecting and Analyzing Fraudulent Claims Using Watson Analytics. My name is Brian Snyder, and I'm an IBM Analytics Client Architect. In today's demonstration, we're going to take the role of a claims investigator, analyst, or manager interested in analyzing claims history and ways to reduce claim fraud. By using IBM Watson Analytics, all those mentioned will be able to quickly and easily gain historic and predictive insights without coding, modeling, and most importantly, without the assistance of anyone else but themselves. This is by no means the Wild Wild West. Administrators still have security and control over the flow of data, only without the complexities and time constraints often associated with reporting and analysis projects. Let's jump in. Let's take a look at the data set we'll be working with today. It's a typical claim set of data that has the amount of the claim, days to incident, whether or not the claim was fraudulent. Let's go into Watson Analytics and bring it there so that we can analyze it and understand where to look next. Here you'll see with Watson Analytics you can explore, predict, assemble, look at social media, or refine your data sets. All the information that is in Watson Analytics is organized into personal folders or shared folders. Today, we're going to be working with this shared folder called Claims Fraud. Let's click Add to add this data source to Watson Analytics, already done in advance. And to analyze that, we just click on its data source and we're presented with a list of questions. If you're not sure which question to ask, there's this question guidance section that allows you to do that. We can go back and actually in this case just choose the fourth question, which has to do with what is the breakdown of claim amount by fraudulent and incident cause. Just by hovering over these data points, we can quickly identify which types of claims had high amounts of fraud. Let's actually take this exploration, save it in a shared location so that others or myself can use it again later. Notice now that it's been saved, it can be easily rerun from that location. At the bottom, Watson Analytics exposes all the raw data that's easily sortable. It gives you infographics as to the distribution of the data. In this case, if we sort on top claims, we can see which claims were the most and if they were fraudulent or not. The bottom allows you to filter easily by using the filter bar, or you can just filter on the visualization itself. I noticed this data set is missing a calculation called average claim count. Let's go ahead and use Watson Analytics in order to create that calculation. In the lower left, I'll just choose calculation, call it average claim amount, and take the total amount of the claims and divide it by the total policy claims. It immediately becomes available, and since it is an average, we're going to go into the selection bar and not only get some data quality metrics on whether or not the other are ready for analysis or prediction, but with this additional option be able to change its aggregate to an average. Now that that calculation is readily available, let's go ahead and in the selection bar criteria where the question is located, change claim amount to our newly created calculation, whether we scroll to it or go ahead and type in search in order to find that easily and change its value. Now that I know the leading causes of fraudulent activity, I'd like to break it down to see by gender as well as by age how these metrics stack up. By using Watson Analytics, I just click and point and add the additional fields, and I'm immediately able to gain insight into which types of claims within gender and age are actually most fraudulent. When you want to see the visualization viewed a little bit differently, just click a button, and in this case, let's take a look at a word cloud, word tag cloud. When using the tag cloud, it's easy to color code it, in this case by age, just by making its selection. And this little slider allows you to highlight those that have fraudulent claims that have an average claim amount that's higher than the rest. A question comes to mind. What is the relationship between age and fraudulent claims? Notice how when you ask Watson Analytics a question, it guides you to the appropriate question. And when your question is complete, you choose the most appropriate question that relates to what you're interested in. In this case, let's make this selection, and we get a network diagram when filtering on fraudulent claims that shows us which relationships actually have, or which age groups actually have the highest amount of fraudulent activity. And by changing it, we can determine if a police report was involved or not with fraudulent activity. Infographics along the top allow us to add in pieces of information that we were not aware of. By saving this and sharing it with users becomes very easy. I can send it as an email, download it, in this case as a PDF, and have all of its information and send it to someone as an attachment or present it in a meeting. Building reports are somewhat biased. Although we found some leading reasons into why fraudulent activities occurred, how can we statistically prove it to our counterparts that we've made a right decision? By choosing Watson Analytics' predict function and choosing the field fraudulent as its target, we can create a type of prediction that will provide us the right statistical background. In order to do that, we first go through each of our data types and make sure that they're marked accordingly for predictive analysis. In this case, a claim number or a customer number is more of a record ID and shouldn't really be considered as an attribute that helps us to understand the reasons why fraudulent activity is created. Once we click Create, Watson Analytics Predict capability comes back with a bullseye. Those bullets closest to the middle are the leading contributors or predictors to fraudulent activity. In this case, we learned that age and a few others that we didn't even consider are part of that predict. The number one leading predictor was police report. In this case, when one wasn't created, gave a 77% predictive strength. That shows that it's a leading indicator. Days to incident is also a leading indicator, and when questioned about the statistical details, it's just a simple click of a button. No need to have a data mining degree in order to take advantage of data mining and predictive. When looking at two at a time correlation analysis, we learned that sunny days where one or less claims is created was a likely contributor. And when looking at all fields in one, this decision tree shows this the number one combination when all fields are involved is the leading indicator as to why claims are fraudulent. Number one here is when we look at this summary pane, and let's go ahead and change this to yes. There's a 49% confidence that days to incident less than 420 in an unknown police report is a leading predictor to fraudulent activity. Notice that this gets saved in my personal folders, and I'm going to move it to my team folder where we can all take a look at it together. And set permissions on who I feel should see it and who should not. Let's discuss the social media project portion of Watson Analytics that provides you with topics and themes such as claim fraud and fraud in insurance over certain time frames and languages from such places as Twitter, forums, blogs, videos, and the others you see here. Let me show you an example of one that I did for another customer who was interested in exploring the sentiment on Twitter regarding some products of Aveeno and Neutrogena. And you'll see here, on a specific day, there was a peak in sentiment that was positive, and all the metrics behind it and piece of information as to who did it, where it came from, has it been retweeted, and other hashtags that were associated with it. Now that we've created a bunch of content across some explorations and predictions, let's go ahead and assemble this in one place as a dashboard that we can even use as a presentation, whether it's going to be a slideshow, vertical slideshow, a timeline. Here we'll just create a tabbed workbook on the web that has a compilation of all the content that we've been marking as we've been going along. So On this first tab, you'll notice I'll expose the collections tab that I've been adding to as we go along. Let's bring this one collection out here. It was that word cloud we created a little bit earlier, and notice the data set is still retained and still fully functional, and in this case we were able to filter on mails that were that had fraudulent activity and still have the ability to change some of those parts of the question. On the second tab, we'll just use another freeform layout and we'll add our predictive analysis. Notice how it just snaps right into play, and really within a few clicks, I can take that, organize it, save it in a public place for others to use, like we saw a moment ago, or even click this share button at the top and send it to them as a link or a way of getting it as an attached email, or even downloading it as a PowerPoint or PDF like we saw earlier. This concludes today's web meeting, where we took the role of a claims investigator, analyst, or manager, and was able to easily use Watson Analytics to look at claims history and try to identify different ways fraud has been created. I'm Brian Snyder, IBM Analytics Client Architect. Thanks for joining.